Right, in this little video we're going to try to help understand double replacement reactions. Double replacement reactions have an ionic compound and another ionic compound reacting. And an ionic compound has a positive ion and a negative ion, an anion, so silver ion and nitrate ion, and copper 2 ion and a chloride ion here. So you can see that we've got a positive and a negative and a positive and a negative. What happens is the positives switch partners. So it's going to make silver chloride and copper 2 nitrate. And so we get a switching of partners, and double replacement reactions happen in water. So you need to consult your solubility table to decide if they're going to be soluble or not. So silver nitrate, all nitrates are soluble. So silver nitrate is aqueous, and copper 2 chloride is going to be also aqueous because it's listed here. Now if it was copper 1 chloride, it'd be soluble, or it would be solid, but instead it's aqueous, it's soluble. And so it's going to make silver chloride, and silver chloride is not. Silver chloride is a solid, and because it's a solid product, we call this a precipitate. I've shortened it to PPT, but it's a precipitate. It's a solid product of two aqueous reactants. Then copper 2 nitrate is CuNO3 2, because we have copper 2 and a 1 negative nitrate. It will also be aqueous. So we've got aqueous, aqueous, solid, aqueous. So to balance this, we want to keep track of our ions, and I like to keep my polyatomic ions, like nitrate, together. So I've got 1 copper, 2 chlorides, I've got a silver ion, and I've got chloride, and I've got a copper, and I've got 2 nitrates. So I've got 2 nitrates, and that's not equal, so I could make these equal if I put a coefficient of 2 for silver nitrate. That means I'm going to have 2 silvers and I'm going to have 2 nitrates. I also will have to make this coefficient 2 to get my silvers equal, and that is also going to take care of my chlorines. So I've got 1 copper, 2 silvers, 2 nitrates, and 2 chlorines. This is now a balanced reaction. And keep in mind that the solid product of 2 aqueous reactants is called a precipitate. So copper 1 sulfate has copper 1 ions and a sulfate ion are going to react to make an iron 3, so iron 3 ion and bromide. So you can see that these two were together. Copper 1 bromide will be a product, and the other product is going to be iron 3 sulfate. So iron 3 sulfate. And my formulas are going to be copper 1 sulfate, SO4. And copper 1 sulfate is aqueous because I check my sulfates, and if it's not listed here, then it's aqueous. My iron 3 bromide is also aqueous. You consult your data booklet. My copper 1 bromide is a solid. 2 aqueous reactants make a solid product. It's called a precipitate. And then I get iron 3 sulfate. So I've got a 3 positive and a 2 negative, so I'm going to need 2 3 positives, and I'm going to need 3 of the 2 negative sulfates to balance it out. So it's going to be Fe2, SO4, and this is 3. This is going to be aqueous. You can consult your data booklet to ensure that. I've got 2 coppers, I've got 1 sulfate, keep it all together. I've got 1 iron, and I've got 3 bromines. I've got 1 copper, I've got 1 bromine, I've got 2 irons, and I have 3 sulfates. So to make my sulfates equal, this is a 3 and a 1, I'll put a 3 here. But that's going to really make my coppers huge. This is going to be 3 times 2, so now that's a 6. I've got 6 coppers, so I can only fix that by putting a 6 here. So the coefficient of 6 applies to both the coppers and the bromines. To make this 6, to make it equal, I need a coefficient of 2 here. And so this is going to be times 2. I get 2 irons and 2 times 3 bromines to give me 6. And now it is balanced. So this is a bit more of a complex balance. But you can see that 3 copper 2 sulfate, or 3 moles of copper 2 sulfate react with 2 moles of iron 3 bromide to make 6 moles of copper, 1 bromide, and 1 mole of iron 3 sulfate. And if I was to compare copper 2 sulfates or copper 1 sulfates and iron 3 bromides, it has a 3:2 ratio of these to these. So 3 moles of this produce 2 moles of this. So that's double replacement reactions. I'll have a video for neutralization reactions briefly, and its neutralization reactions are the exact same kind of reaction, but now using acids.